All right. Good afternoon, everyone. I'm Chainarong Today, I'm going to present our work in the topic, coordination event detection and initiator identification in time series data. Let's see, concept and motivation. Here, this work is about leadership, and we define leader as pattern initiators. A leader is an initiator who initiates some movement and then everyone follow. Well, here's our inspiration when we look at the animal data like this. Here's a question. Who are leaders of this animal, and how can we measure leadership? So nowadays we have GPS devices that we can use them to track animal positions. Here's the example of baboon trajectories from Kenya that Professor Crowfoot, one of our co-authors, collect them in 2012 in Kenya. Here's a question. We have time series or positions like this. Who are leaders and how can we infer them? How can we infer coordinate activities and group decision intervals? And lastly, what is the mechanism behind that create the coordination? Do baboons have the democracy? Do they vote when they feel hungry and want to go to the feeding site? Or they just use dictatorship model? And lastly, how can we answer above question computationally? So in this work, our contribution is to formalize the new problem, Coordination Initiator Inference Problem, and we propose our framework called FLICA that can be used to detect coordinate activities, identify who is the initiator or leaders, and lastly, classify the group coordination model. So first of all, let me introduce you about the concept of following network. Suppose we have two time series, toy time series like this, Q and U. Q creates some patterns, and then you follow the same pattern with some time delay. Well, the following network is this. The nodes in the following network defined as individuals, and the S is a following relation. If U follow Q, we're going to have the S from U to Q. Here's the definition of following relation. It seems a bit complicated, but it's just that if time series U is the same as W with some time delay, so following relation happens. And how do we know when the coordination happens? It's just simply that the coordination is a time that when everyone is following someone. Lastly, initiator. The concept of initiator is just the first individual who is followed by someone. So, method. Here's a high level of our framework. We start with the input as a time series data set. And then we create the dynamic following network. And then we're going to use this dynamic following network to do many analysis from coordination interval detection, leadership measure, and rank comparison. So again, here's a following relation concept. But now, let me introduce you how to infer the following relation. We use dynamic time warping. Well, but we cannot just look at the distance of the dynamic time warping because it never gives the relation like a who follow whom. So instead, we look at the dynamic programming matrix of the dynamic time warping. If you look at the warping part like this, if you create some pattern and then, if Q creates some pattern and then you follow, the dynamic time warping gonna match the pattern of U back in time to match with the Q pattern. So when we take the difference between the index of Q and U in the optimal warping part, we're gonna get the delta T, the time delay. So after we know how to infer who follow whom relation, the next step is to create the dynamic following network to do some analysis. We use the sliding window technique for the entire time series. We're gonna separate them into the small interval And then for a small interval, we create the following network that represent that interval. After we cover the entire time series, we're going to have a time series of dynamic network density like this. Here's the interesting point. Well, when the group of baboons, let's say, for example, coordinate to somewhere, we're going to have pretty high value of network density at that period. We call it coordination interval. And period before that, we call it pre-coordination interval. So how can we rank who is the leader? We use PageRank. Here is the example of 3 time steps of the real baboon following network. Time T1, T2, and T3. The node size represent the value of the PageRank. The S represent the following relation. Well, at time T1 and T2, it is in the decision-making interval. The black node is a leader who initiates the movement. This black node encourages everyone to move. And then here's the interesting thing. After we pass the decision-making interval to the coordination interval, the blue node hijacks the group, and then the blue node leads the group instead of the black node. If we aggregate the entire network and we don't care anything about decision-making interval, we're going to conclude that the blue node is a leader, which is not true. Actually, the black node is a true initiator who initiates the group to move. So we have 3 types of leadership here, global leadership. Suppose we have time series like this. Time series of network density like this. The global leadership is the way that we find who is a leader when we looking at the entire time series. Well, another concept is a concept of local leadership ranking. We have the rank order list for its coordination interval, because we can detect which period is a period of coordination interval. So we can do the ranking just only specific period like this. And finally, initiator leadership is a leadership ranking that we calculate by using only the decision-making interval to conclude which one is a leader. We don't look the entire time series interval to define which one is a leader like global leadership. We just look at the decision-making interval. So let me introduce some leadership features that we propose that might be useful to do the model classification later. Well, along with the PageRank value, the way that we can do the analysis in the time series about leadership, we use velocity convex Hall. The way that we calculate is easy. For each individual, we just count the number of times that each individual I has a velocity greater than the entire group from the previous time step. The concept of velocity convex Hall represents who is the person that's moving first. And the concept of position convex Hall, we calculate by just looking at the number of times that individual I position is outside the group area from the previous time step. In this concept, we try to measure who is an individual that seems to explore new area before author. So let's move to the result. So as I mentioned, we have 3 types of leadership: global leadership, individual who lead the group for the entire, mostly the entire time, or initiator leadership, leader who leads a group just mostly in the previous of decision-making interval, or local leadership. Suppose we have many coordination events in the time series. For each event, we can have the local leadership. To make it clear, let's say baboon in the morning, we may have one baboon who leads a group to the feeding side. In the afternoon, we may have different baboons. that lead the groups to the sleeping side. So different time, we can have different leaders. So that's why we cannot just simply look at the global leadership to detect which one is leader. Sometimes leader is kind of the represent initiator that based on the context. So here's the result. The left-hand side is simulation model. We have many simulations. Like DM represent dictatorship model. We have a single individual who lead the entire group. This one, this leader, when it's moved to somewhere, the entire group just follow. The SM is a hierarchy model. It's like a king that king lead the group, and then queen follow king, and then jack follow queen, something like that. We also have many more models. And then we have three set of art methods, like a flock, IM, and LPD. Three of them, all of them, these three methods can infer just only global leadership. They cannot infer the coordination event, so they cannot calculate the initiator leadership and local leadership like our framework. And yeah, if you look at the green one, global leadership, our framework is pretty competitive. For the red one, it seems that our framework can infer the initiator leadership pretty accurate too. And for the yellow one, for the local leadership, that we simulate many coordination. For each coordination, we have different leaders. Our framework also has pretty high accuracy to detect leaders in this model. Well, let's move to the right-hand side table. It is the result from FLICA. We have a school of FLICA trajectories. There are two types of FLICA, trained FLICA and untrained FLICA. The trained FLICA know the path to the feeding side. The untrained FLICA just follow the group. The task is that we want to detect which one is the trained FLICA that initiate the movement, and then everyone follow. And here's the result. Our framework can detect the trained FLICA with the accuracy at 83%. Yeah, compared to the set of artworks. All of them just fail to detect this noisy data set because they just use the simple way to define leadership, like direction or velocity features to define which one is a leader. Here's an interesting thing in another data set. We have NASDAQ stock market price index on the right-hand side. And on the left-hand side, it is a time series of network density, following network density. Here, we can detect the important event. If we look at the event in 2007 to 2009 in this area, the entire stock market just fell because of the crisis. And well, here on the left-hand side, our result of network density also, we also have pretty high network density in this period because the majority of companies in the stock market just coordinate to fall down. So that's why our framework can detect the coordination and has the pretty high network density here. Lastly, about the result of leadership or model classification. As I mentioned before, we propose the way to measure the characteristic of the time series in the leadership aspect. So we have many simulation models here. The different color in the 4 plots here represent the feature space, and the different color here represent different models. For each point, it is the data point, like the set of time series that generates from that specific model. Here, we can see that on the right-hand side, it is a result of the model classification from a 10-fold class validation by using random forest. And yeah, our features perform pretty well here, mostly. And here's the interesting thing. If we have the real-world data set like a baboon, And we start asking the question, do baboon have a dictatorship model when they make the decision to move to somewhere? Yeah, by placing the baboon time series dataset features to this space, we can do the hypothesis testing and try to address this kind of question. So in summary, in this work, we formalize the Coordination Initiator Inference Problem. Our framework, FLICA, can be used to detect coordination activity events, identify who is the leaders, and classify the group coordination model based on our proposed features. So our results show that our framework is pretty competitive in the task of leadership identification. Our framework can show many majority events in NASDAQ stock market. And finally, our proposed features can be one of the options to use to do the model classification in the leadership aspect. Thank you.